Hello everybody, welcome to In a Few Tech. In this video, we will provide a high-level overview of reinforcement learning. This topic has gained significant attention recently, especially with models like DeepMind's AlphaGo, which was trained using reinforcement learning. Imagine a computer program that learns to play chess, not by analyzing millions of games played by humans, but by playing against itself, over and over again, learning from its mistakes. It gets better with each game. This is the power of reinforcement learning. Reinforcement learning, or RL, is like teaching a dog new tricks. We give treats for good behavior. The dog learns to repeat actions that lead to rewards. In RL, the dog is an algorithm. The tricks are desired actions, and the treats are rewards. RL is revolutionizing artificial intelligence. It's the brains behind AlphaGo, the program that beat the world champion at Go. It's also used in self-driving cars, robotics, and even personalized recommendations on your favorite streaming platform. This new kind of learning is changing how we interact with technology, and it's just the beginning. Let's break down the key players in the world of RLO: agent, the learner, the decision maker, like our chess-playing program. Environment: the world the agent interacts with, the chessboard in our example. State: the current situation, the position of all the pieces on the board. Action: what the agent chooses to do, moving a pawn, for example. Reward: the feedback the agent receives after an action. Winning the game would be a big reward. The agent's goal is simple: maximize its rewards. It learns by trying different actions and observing the outcomes. Over time, it develops a policy, a strategy for choosing actions in different states. Think of it like navigating a maze. The agent explores different paths, learning which ones lead to dead ends and which ones bring it closer to the reward, the exit. This learning process relies on something called a value function. This function estimates the long-term reward associated with being in a particular state. The agent uses this to prioritize actions that lead to states with higher values. Reinforcement learning might sound familiar. It shares similarities with other types of machine learning, supervised and unsupervised learning. But there are key differences. Supervised learning, like learning from a teacher with labeled data. Imagine learning to recognize cats from pictures labeled cat. Unsupervised learning, finding patterns in data without labels, like grouping similar customers together based on their purchasing behavior. RL is different. It's about learning through trial and error. There's no labeled data. The agent learns from its own experiences. It's more like learning to ride a bike. You fall a few times, but eventually, you figure it out. Reinforcement learning uses Markov Decision Processes, or MDPs. MDPs help agents make decisions in uncertain situations, like deciding to take an umbrella based on the weather forecast. The state is the forecast. Actions are take or don't take the umbrella. The reward is staying dry. MDPs help plan for long-term rewards. Balancing exploration and exploitation is key. Explore new actions or exploit known strategies. Reinforcement learning is a powerful tool for creating intelligent systems that can learn and adapt to complex environments. From playing games to driving cars, reinforcement learning is transforming our world. And as this technology continues to evolve, we can expect even more exciting applications in the future.